Good evening, everyone. Tonight I'm going to talk very briefly about the AI scientist from Sakana.ai. And I'm not going to be live for that long just because I do need to go to bed very soon. But I did want to talk a little bit about this because this got me thinking a bit. And I think it has definitely made its rounds on the internet. For those of you who have been following my channel for a while know that I have made a video about the AI scientist. This was about 6 months ago. So if you haven't seen that video and you want to see what I was thinking about 6 months ago, feel free to take a look at this video. But I did want to talk a little bit about the peer-reviewed publication. So they released this blog post on their website here, and they talk a bit about the AI Scientist version 2, which is the version that created this paper. And this experiment, it says, was done with full cooperation of this conference or this workshop organization. And they submitted three AI-generated papers for peer review. The reviewers were informed about the possibility and likelihood that the papers might be AI-generated, but they were not told in advance if they were actually AI generated or not. And hello, people in the chat. Hello, Jacob Schenk. Hello, Lloyd Nebris. Good to see you all. And hello to everyone else who's joining live or not live if you're watching this after the live is done. Welcome. I just wanted to talk about some of my thoughts on the matter here about the AI scientist because obviously it's a really big deal, to put it lightly. And so, like I said, three papers were submitted that were AI generated. So these three were the ones that were AI generated. The only one that was actually accepted formally was this one up here because it received the highest average scores. And to be honest, if I click on it and I try and read it, I don't know enough about compositional regularization. But nevertheless, Sakana AI has gone through the paper itself. They've left a bunch of comments on these paper submissions and have pointed out things that are just not correct or some slight inaccuracies and things of that nature. So the thing is that's interesting about this, though, is that they're saying that the AI Scientist 2 had done the whole process, right? So the papers were generated completely end-to-end by AI without any modifications from humans. It says here, AI Scientist V2 came up with the scientific hypothesis, proposed the experiments, wrote and refined the code to conduct those experiments, ran the experiments, analyzed the data, visualized the data, wrote every word of the entire scientific manuscript from the title to the final reference, including placing figures and all formatting. It says here, we as the humans overseeing this research merely gave it the broad topic to perform research on because the topic should be relevant to the workshop we submitted to and picked 3 AI-generated papers to submit. We chose this number following discussions with the workshop organizers to avoid overburdening reviewers. So what ended up happening here was that these were the papers, those are the ratings of that paper that was accepted, this one here. And it says here, however, as we will highlight in the next section, it was determined ahead of time as part of our experiment protocol that even if papers by the AI scientists were accepted, we would withdraw them before they were actually published. This is because they were AI generated and the AI and scientific communities have not yet decided whether we want to publish AI generated manuscripts in the same venues. Okay, so now this is obviously a big deal, and I do not want to take away anything from Sakana.ai. It is no small feat that they were able to go end to end, or its AI model was able to go end to end to create this work. Now, you have to imagine this entire paper just being completely done end to end by a artificial intelligence model. Again, can't really comment too much on this, but I will say a few things. Couple of things here. Okay. So one of the things I will mention is the paper that did get accepted. So this is, I believe, more of a workshop paper. Okay. Now, to my understanding, and it might be different in the computer science / artificial intelligence field than it is for physics. Okay. But there's a difference between submitting to, for example, a conference workshop, like a conference paper, versus a peer-reviewed journal. That might be different in AI and computer science. I've heard that and I've read that it's a big deal to get these papers accepted. I mean, it's a big deal to get your paper peer reviewed and accepted anywhere really. But from my understanding, like for physics, when you submit to a conference paper, the thing that you're submitting doesn't have to be a completely polished and final work, and so that the barrier of entry is lower than it would be for publishing in a standard journal. And so that's, again, not to try and take away anything too much from it. I just want to sort of have some context here and have people understand that there is, in my mind at least, a difference between getting a paper through a workshop conference kind of thing versus a journal that will be published and be I would say published in print, but I guess it's electronically printed these days. Things don't really happen on physical paper anymore. But nevertheless, this is still really impressive. The one thing I will also say, though, is that it's just really short. Just by looking at this, it does feel a little bit... It does feel... I mean, this is a very short introduction. This is a very short related work method. This method section is really short to me. To me, personally. I mean, I don't work in AI, and maybe this is just how things are, but... if you work in like the physical sciences, this is really short. But again, they're talking, we're going to use an LSTM based neural network. Okay. So I guess, we're just saying this is a known thing. And so, maybe we don't need to expand upon it that much, but it does feel like a really short paper, right? Like this is a 4-page paper compared to something like, in physics or like chemistry or something. I've seen papers, right, that are 15 to 30 pages on average, right? So this feels a little short, but this could just be the fact that this is a completely different field than what I'm used to. Did they say why the authors are designated anonymous? So I think it was designated anonymous because, one, it was AI generated, and I think what they wanted to do was I think this conference ICLR I think they agreed to do a double-blind study, I think. Yeah, so they did a double-blind review. So the authors don't know, the right people who wrote this, well, the AI who wrote this, if it was humans, the humans don't know who's reviewing them, and the reviewers don't know the authors who wrote the paper, right? So I think that's why the anonymity was put in there. It does look really cool. I wonder if I can take a look at these images more closely. Okay, so this is just the paper itself. Okay, so this is the paper without the annotations. Okay, I see. Oh, and there's supplemental information too. I didn't see that. Is there more supplemental stuff? Okay, there is, but it's only... Oh, more pages. Sorry, I didn't see the more pages. Okay, so it's a bit longer here, actually. My bad. So how long is it actually? It's 8 pages. Okay. Huh, interesting. So this is the setup here. Can we take a look at the... Can we take a look at this? So this is the loss curves. So these plots are actually made by the AI scientist itself. So it does a bunch of training tests here. Okay, so it's comparing LSTM and RNN. Positional weight ablation test accuracy. So it's changing I guess that's the regularization parameter. I'm guessing it's changing. And dropout impact. Okay. So they did some experiments here. It says this conclusion here seems wrong. From the figure, the attention augmented performance much better than the baseline LCM, where the former reports 100% final test accuracy. The code review for more details. Okay, so it does seem that the AI scientist v2 doesn't necessarily interpret its results completely accurately, which is also kind of interesting that it got through peer review. So here's another thing. I also want to... No, I'm not going to have time to do that, unfortunately, IID, to react to DeepSeek. I'm only going to have time for AI Scientist tonight from Sakana. But here's how I think about this, and it might be a bit of a, I don't want to say completely dissenting opinion, but there's a couple of things here, a couple of these comments that make me think about a couple of things here. It says this is a stretch because the paper has not rigorously shown that lower compositional loss leads to more compositionality. This claim cannot be inferred from figure 1. This figure lacks an explanation for the shadowed area, which would be clarified as a representing the standard deviation across 3 or 4 independent runs. So here's the thing. While it's cool that it got through peer review, it obviously has some mistakes or some just, it's making claims that can't be backed up. I've noticed this too, where AIs will say things. I mean, of course, they'll say things really confidently, but then there's really not any supporting evidence to say this is the case, or it just completely interprets itself wrong. Like, I think when it was looking at the figure down here, right, in this figure 5, it seems that the models are not able to just look at their graphs and draw immediate conclusions, which, might just signal some weaknesses with the vision model aspect of the AI scientists. I don't know actually the composition of this thing. They're coming out with a paper on that later. But what I think I would be really impressed with, and not to say this is not impressive, but I think what would really, really make me think we're coming closer to, I don't know, I don't want to say AGI or ASI, but powerful AI, more powerful AI, is that obviously it makes complete sense that the first domain of application is going to be in AI itself, and having AIs do things that can be completely done on the computer. Okay, so that makes total sense that you'd want to test these things by first having them do experiments that can be completely done on a single workstation that it has complete autonomous control over. But then I was thinking about just what I was doing as a grad student, right? And when I was a grad student and I was, looking through telescopes this is me controlling a telescope from my apartment during COVID. So this was kind of a rare exception where they let us do this because we couldn't go there in person. But I was thinking about, what kind of goes into doing science, physical sciences or observational sciences like astronomy, right? And having all these kinds of panels, all these kinds of, planning that goes in advance of just determining, how long do you want to, observe a target, and, which spectral lines like you're looking at right here do you want to look at, and how do you interpret the line widths, and how do you interpret the shape and the positioning of these lines to gain some sort of physical insight. I was thinking about this, right? And I think what would really impress me is if an AI can do that, right? And I don't think we're quite there yet, because if the AI is misinterpreting its own figures in these, training runs, and it's suggesting that its vision model may not be able to just look at, a graph and draw some immediate conclusions from it, I would be very, very skeptical of giving it, control of like a research grade telescope and trying to make heads or tails of these plots and these diagrams, and just understanding the nuances of instrument control and sort of the fine adjustments that have to be made in advance. So again, this is not to be too critical of the AI scientist. I still think it's very impressive that it was able to go end to end, come up with its own idea, make the code for it, do its own experiments, things of that nature. At the same time, it does feel like, okay, it's limited to the computer right now. So I kind of want to see it move out, but I think that will require like robotics, right? Or some way to interface with the real world, quote unquote. And let's see here. Let me see here. What do people say here? I think I missed the first couple of minutes here. Did this kind of just say how long? Oh, that's a good question. How long did it take here? I don't think, did they say how long? Took, let's see, time. Okay, we encouraged the to prove that worked several times. Yeah, it doesn't say. I don't think it says how long they took. I think that'll probably get published in the AI Scientist V2. I think they're going to publish that. But I don't see how long it took them. That's a great question, Lloyd, but I don't see that here. Repeat each of experiments several times. Someone says here, is this AI scientist just hype, or is this a significant step into AGI? I guess it depends on how you look at it, right? So the papers themselves, people can access the papers themselves on GitHub. So just for some quick catch up for people who just joined, Sakana submitted 3 papers to a conference. Okay, these 3 papers right here, you can look at them. Only one of them actually got into the conference, which was this one. It has the highest average score. You can take a look at the reviews and also the annotated paper itself, where the Sakana team actually annotates the paper itself. So the paper that got in was 8 pages. Well, technically it was only 4-ish pages because the pages 5 through 8 are really the supplementary stuff. So it was really 4 pages. And to me, it's hard to comment because I'm not an AI researcher by training, and I don't have the familiarity with how novel this thing is, and if what it accomplishes is really that groundbreaking. I was commenting earlier that there is kind of a difference, in my mind at least, of publishing a paper or getting a paper through peer review for like a workshop or a conference versus getting a paper through into like a scientific journal like Science or Nature. Now, Science and Nature are like the top kind of journals, but not even those top journals, I would say that the barrier of entry into a journal, into a scientific publication that has a high impact factor, is going to be more difficult than for a workshop paper. Okay, so let's put that into some perspective. Again, not trying to be completely a downer here, but I'm trying to give you some things that go off in my mind when I hear this. It's like, okay, was this paper in a conference paper, or was this a journal paper? Okay, so it's a conference paper. So if it's a conference or a workshop paper, then to me that's like, okay, so I just inherently have already just lowered my expectations of like, okay, so this work is maybe not necessarily going to be fully complete. Like conference papers are usually for things that are in progress that may not have final results yet. So it's okay to be kind of vague and abstract a bit. So that is what I first thought when this came. The second thing I wanted to see was just, how does it write its method section and its different sections. Now, it's very terse. The thing I notice about AI models when they write papers or write just these kinds of description, let me take the other 2 really quickly because I didn't actually take a look at them. How short are those introductions and methods? Yeah, I mean, this method is really just not, like the way I would describe this, and it might be hard for people who may not do this on as like a profession, but this is, I would say, not very acceptable as a scientific publication because, like, yes, it's using the right words or whatever, but it doesn't feel comprehensive enough for what's the word I want to use? Reproducibility. That's the word. Yeah, reproducibility. The way it writes, I've noticed when it makes papers like these, is that it's very, it's just very brief and doesn't really go into depth. And then, plots like this, right? You don't make plots like this in papers like this. You might be wondering why not. I mean, okay, this is something we teach, right? You got to be able to look at the graph, right? And this is covering a good portion of the graph. I guess these 2 are fine or whatever, but there are just some decisions just by like looking at how the plots are made, or just the lengths of certain sections, or the lack of discussion in certain sections, that make me think, yeah, this feels just not detailed enough for for like a serious publication. Let's see here. Someone says here, la 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 la. Perplexity says Sakana's AI system took 7 months to write its first paper that successfully passed peer review. 7 months to produce 7 months to produce this paper here. Okay. Yeah, that feels a little. That feels a little. I don't want to say disappointing. I mean, okay. I'm gonna hold my tongue for a sec. I'm just gonna read more comments here and see what people say. How does Sakana manage confidential info? Do the models store the data you feed in? I don't think any of this is confidential. I think everything that it's doing is basic AI research, not basic, but fundamental AI research that is done on publicly trained data sets. So if we look at their experimental methods here, it says we generate synthetic data sets of arithmetic expressions to evaluate compositional generalization. So all of the data sets I think they use are all publicly available stuff here. So let's take a look at the third paper. I didn't even look at that. So this is label noise. How did they study this? Okay, it says we use 3 data sets, CIFAR, MNIST. Okay, these are very standard public data sets. So everything that it's doing is either data that it creates synthetically or it's publicly available data. Is it kind of initializable from the GitHub? I don't know. We can take a look. I wouldn't know how to do it myself though. Let's take a look here. Can we initialize it? Launch? Oh, I guess you can launch it. So how would we do that? Installation. There is an installation here. So I guess if people want to try and run it, looks like you can. You can use, there's a lot of API support here. Literature search, setting up the templates. Yeah, so if people want to, people could try and install this. You can also run the paper generation experiments yourself here. I would need some time to set this up. Over here, community contributed templates. So yeah, I guess if people want to try it themselves, feel free to go to the Sakana website and, sorry, that's just the chat here, and try it yourself. Yeah, so going back to sort of what I was saying earlier, there's something about this that feels a little funny, and it's very subjective, which is why I don't want to be too brutal in my assessment. But and you have to understand, I come from a completely different area of research and science, and so the standards may not be exactly the same. But this feels like, how do I say? It feels kind of amateurish at the moment in terms of the its ability to produce things. Like, this feels like it's AI generated now, but maybe it's just because I'm used to seeing AI generated outputs since ChatGPT for a while now. Like, there's some things about the way that these papers are structured that makes me feel like it's just so terse. It doesn't write, it doesn't really go into detail. Let's see, are the experiments more depth may be required? Yeah, I mean, the comments are even picking it up here, like more depth might be required. Few studies have addressed, it's not entirely accurate. Downplaying previous contributions. Citations not properly handled. This claim is not entirely accurate. Let's see here. It says here, all the science generated reliability diagrams during the experiments, they were never included, included in the paper. And they even got their, looks like they even reported their techniques incorrectly here. These comments are actually really helpful because it's already showing just where these shortcomings are, actually. Yeah, there are no ECE figures here, no experiments for this. Can you say more about Sakana's model? So I did have a video on Sakana AI Scientist a couple of months ago. I don't have, I don't think they've released their model publicly yet, or in the sense that they're writing a paper on V2. The version that made the papers is AI Scientist V2. And I don't think they have they actually just, oh, maybe they have, okay, so they have some code here. Okay, so maybe we can take a look at some of the code here. Automated relation, carpe diem. Good evening, Curtis. Good to see you. I'm just taking a look at some of this code here. Okay, so they have some generate ideas here. So it has some like scripts for like generating ideas. Okay, wow. So if people really want to take the time to go through the code, be my guest. I'm not going to have time to do that tonight. I just wanted to talk a little bit more about what I think is going on here. Someone says, do you feel like you've had a privileged, lucky, easy life or a hard-fought, rough life? Probably something in the middle. Like, I don't feel like my life has been like a complete cakewalk, but it hasn't been like the worst life ever. Easy win. Let's see. Do you think that the level of detail that is lacking for this to feel solid and reproducible will be solvable by a simple increase in compute, or why is limited to this non-detailed scope? Yeah, that's a good question. That's a good question, Daniel. Do I think it could be solved with test time compute? I think, and I have no basis in reality for this, so take what I say with a grain of salt. But what I think might be the issue is that, to answer the question, I don't know, but I'm somewhat leaning towards no in terms of more test time compute for more descriptive, the way it writes. Because there's a lot about this that suggests to me that it may not actually fully understand completely what it's doing, which is a very bold claim, but based on some of the comments that Sakane themselves have put out, there's evidence to suggest that it doesn't really seem to fully grasp the results it gets, right? So if you look at like paper 1 here, let's see here. Where was that one comment it said? This claim, yeah, it says like this claim cannot be inferred from figure 1. There was also something else about the plot where it was like, oh, this plot does not actually show this, or it interpreted one of its graphs incorrectly. Where was it here? Is this the right paper? Maybe it was. Yeah, so let's see here. It outputs seem, in a sense, very vague. Typically with method comes the rigor or like math offended, but the math does not, it doesn't really align with the methods. Yeah, so that's kind of what I feel too. That's what I feel as well. Like the way that it introduced, like the intro, like this method here is like very, like our goal is to enhance compositional generalization by incorporating a compositional regulator term into the training loss. We focus on a simple yet illustrative task, evaluating arithmetic expressions involving basic operations. Okay. So yes, I mean, like this is the methods, right? Like this is the methods. Now again, very different from what I studied in grad school. Okay, so this is their loss term here, and so they're doing some sort of regularization thing here. Training objective. Okay, so yeah. Someone says here, Kyle, I'm curious if this could be used as a research system. What I'm looking for is a tool to help me do some of the basic math steps, do all the LaTeX formatting and output. I think the LaTeX formatting and output is fine. Like if you wanted to just write out your LaTeX for you, if you gave it everything to write out. So I'll give you a really good example. I was able to get it to like convert some like handwritten notes I had into a LaTeX document that has, more or less, pretty accurate representation of what my notes said. But in terms of a research assistant, this is where it gets a little bit tricky. I think if you gave it the instructions, like I think the humans, this is what I think. I think the humans still need to come up with the experimental design and like the methods. But I think if you give it in a readable format to an LLM like this, or maybe that's not even the right term, but a reasoning model like this, it could run the experiments for you, right? So for example, if you told it to, have a training set of this much, this sample size and this sample size, and you train for this epoch, if you gave it like everything, like the recipe of what you want your experimental, machine learning run, if that's what you're doing, is, I think you can do that, right? Can you post the links to the papers? Yes, the links here. People wanted to get the links. The links are here. I did post them earlier in the chat, but if you go down to where are the papers? Example papers. Hello. Let's take a look here. Let's go back here. Okay. Here we go. If you want the papers, they're going to be over here. Let me pull them up. Yeah, actually, Curtis, one actually interesting thing is that people may not know this, but one thing I've had to do is that there are some books, right, that have like code in them. This is not a book that has good example, but one thing I've done is that sometimes there are these books that have the code in them, like in Python or whatever, and I don't want to have to, and I don't post it online. It's just in the book, and it might be 100 or 200 lines, and it's like it's not like impossible for me to copy all that down. But what's just much easier is just like take a picture of my use my phone, take a picture of it, and just tell ChatGPT or Claude, just, hey, based on this picture, please just verbatim copy this code, and then it will do it, right? So that's one really interesting aspect. So I think in terms of giving it instructions and having it run these ML experiments is fine. I don't trust it to come up with the experimental design itself that well. And again, let's just put some context here. The paper that it got submitted to, I keep repeating this, but people keep joining at different times. So I would say that this was submitted to a workshop or a conference. And I think, in different fields, it's different benchmarks of prestige, but in my mind, conference papers are they're easier to get through peer review than, let's say, a journal paper of a high impact factor, right? That might be different in computer science or AI. People can tell me if that's the case, but at least in like the physical sciences, like physics, I would say that conference papers are typically for papers that are not fully done yet and are still in review, and might eventually become their own paper at some point in terms of a scientific publication. Okay, on a scale, what is the level of academic rigorosity you would give this paper? So, in terms of what the team gave, what the reviewers who reviewed the paper that actually got in, so they actually submitted 3 papers, okay? 3 papers they submitted to this conference. 1 got in. This was the one that got in. This is the one that had the highest average score. And I don't know. I kind of want to give it like a 5, honestly, out of 10, which I know doesn't sound good, but, and I'm not even a researcher in this field, so I feel like I don't even have I don't think I'm a fair judge, but I feel like it's just not detailed enough. Like, I think the reproducibility factor, I mean, the experiments it also runs are, I think, fairly basic, I suppose, just based on what I read. But there's something about it where I don't feel like it has enough rigor. And I don't have a great way of measuring that, though, other than just how it reads and what it cites or what it doesn't write, expand upon. So, yeah, that's kind of how I feel about that. Would a human scientist ever write this poorly? Yes, I think they would, and they have. So, in that regard, I think it's, maybe that's a fair point. But I don't know, if they have a PhD, I feel like they would, if this was their field, then I would say like a grad student who was new probably writes like this, you know, who doesn't like people who write like this typically. This, you know what this reminds me of? This really reminds me of how I wrote this one review paper when I was a first year in grad school on this topic I had like no idea about. I've showed it on this channel a few times, but I wrote this research review paper for this field known as density functional theory when I was a first year grad student, because I thought I would study density functional theory. And I can't even tell you much about density functional theory today. But I remember I wrote this like 5-page review paper, and it was really vague. If you read it, it sounds very vague. Yeah. It sounds very, very vague. Like, hold on. Let me give you a good example. I'll give you an example of what this reminds me of, and you can be the judge. Let me go to my Overleaf if I can sign in really quick. Hopefully I don't leak my passwords or anything. One sec. I'm going to put this on another screen so I don't dox myself or whatever. Oh, good. I could just use two-factor. Thank you. DFT. Okay, here we go. So people may have seen this before. But I want to give you a sort of a comparison, okay, of how I feel like this reads compared to something I wrote myself, 8 years ago at this point, right? So this is a paper on this is a review because I thought I wanted to do density functional theory back then. I didn't end up doing it. But if you read this, okay, and people can actually read this. Actually, I don't mind sharing it. If people want to roast me, it's fine. Turn on link sharing. View the project. Here, I'll let you guys read it. Let's see here. Okay, so if people actually want to read the paper, you can, what I wrote here, it's right here. But if you actually read my review of this subject of DFT, it really reminds me of how this paper by the AI scientist reads. Because first, I'm just writing about facts, right? You write about a bunch of facts and you don't really talk about your own original thoughts, which I suppose the AI scientist did, but I feel like a lot of the time for people who don't have confidence in their like scientific knowledge, you're just going to write about all the things that are all like universally accepted. So none of this is wrong. Like nothing that I'm saying is wrong, but also nothing that I'm saying is original in a way. Okay. And so, I mean, all these figures too are like from different reviews and stuff here. So when I'm reading this, it says it's worth observing the popular functional that shows the progression of DFT throughout the years, yada, yada, yada. Again, everything here is like what's been done. And again, this was a review paper, so I guess I am not really putting my own opinion on this, but this is the same kind of vibe. I know that word's been like being thrown around a lot, right? Vibe. But the vibes here give me the vibes from what the AI scientist writes. And now that I'm reading my own writing, okay, I don't mean to be narcissistic, but I kind of like my writing more than I thought I would looking back, but it does feel kind of like an amateur here. Like everything I'm writing here, these are all just speculations from like other people, right? I don't have like almost any original thought in this as a review paper. AI scientist versus Kyle, I prefer Kyle paper. Oh, thank you. I appreciate it. I mean, even though they're completely two different fields, but I appreciate it. It says here, is the length of paper a factor in its rigorosity? Is 0.1x the length it should be? I don't know if it's 0.1x, but I feel like it's at least 0.5, if not 0.25. Like, I feel like the paper that they wrote could be twice as long. And scanning it feels warmer, pun intended, LOL. Yeah, like, okay, let's go back to the AI scientist paper really quickly. Let me take a look at the ones that didn't pass. That might be better example. Like this one had a 3. So it says here, we demonstrate that standard mitigation techniques offer limited improvements. No empirical evidence for this claim. Okay. Label noise, blah, blah, blah. Pervasive learning. Genesis minor, we disagree. Issue. Related work. Okay. Few studies that address methodology. Yeah, this methodology is just really, I don't know. It feels just so not rigorous. Okay, training procedure. I don't know. Okay, it's just like I think my PhD advisor would not let me get away. It's like my PhD advisor would be like, if this has to be just 2 sentences, then you'd probably make it. You'd probably just, instead of having like 4 subsections, you'd probably just have 1 or 2 larger sections. Like, I know this is very stylistic and not really rigorous, but it's very just not how I would write the paper. But again, this is AI. On the math methodology section, sus. Oh, okay. So if people are curious about this, I think what's going on here, yeah. So this is meaning that the citations are not properly handled. So oftentimes when you're writing a paper, right? Just to give you guys some context, right? When you cite a paper, like in LaTeX, for example, what you often have to do is cite something like this, right? You see where I have like cite here. So what I'm guessing is that it just cited the wrong, like if you cite this incorrectly, like let's just say, where's this thing? Estimates the number of properties, introduction. So if I don't cite this properly, like this DFT holes thing, let's just say let me just remember that's DFT holes. Okay, what if I go down here? Probably where does the question mark come up here? Estimates of the number of papers. Oh, okay. Yeah, so you can see that the citation, okay, it's not a question mark, but it's just a blank here. But sometimes, depending on the formatting, if you don't cite it correctly, let me just put it back. It should come back here, right there. Yeah, now it's back. Yeah, if you don't cite it properly, then it comes up with these question marks. Yeah, I mean, this paper looks really rushed. I think that's the best word. I think that's how I would describe it. How does this compare to other AI papers you read? I mean, we can compare, right? Let's go ahead and let's compare. Let's just go to arXiv. So people don't know, if you go to arXiv.org, there's all these papers, right? Let's just go to AI, right? Let's go to just a random AI paper. I'm going to go from Monday, right? Broaden your scope. Efficient multi-turn conversation planning for. Okay, let's just go ahead and pick a paper like this. Okay, look at this. This paper is 25 pages. This is a conference paper, right? Like this is a conference paper at ICLR. This is the same conference paper, same conference as the AI scientist paper got in. Okay, so they said ICLR 2025. This one is 25 pages, right? So here's the abstract. Here's the intro. Much longer. Here's the figure. Okay, like I know we're kind of just skimming by it, but just look at the difference in terms of like the depth. Like here's your intro. Okay, what was the intro for the AI science? Let's get the paper that was actually accepted. Okay, I don't think that was the one that was actually accepted. Let's get the one that was actually accepted. Just kind of have a fair one-to-one comparison here. No, whatever. I'm not going to download it. It's fine. Okay, the intro, like this is the intro for this one. This is the intro for the one that was submitted by humans. This is a human paper. It's kind of funny saying that, a human paper. Oops. Go back here. So it's 25 pages. This is the intro. This is the problem set. I mean, look at this, right? This is like they're setting up the problem here. They actually have the mathematical like notation here in terms of explaining this. Like they have a bunch of equations here. Okay. Like this is like, just compare this to this. Okay. Like, yes, there's some equations here, but it's almost as if they're trying to avoid writing equations, Because I feel like when you start getting into stuff like this, which I don't, this looks like some sort of reinforcement learning policy search thing, which I could be wrong here. But, oh, it's Monte Carlo tree search. Okay. But you sort of just see the difference in sort of rigor and language. Okay. And this is the paper that got accepted. Okay. This is the paper that actually got accepted. This is another paper that did this get accepted? published as a conference paper. Okay, so it did get published. So this is one that actually got in. I'm glad I picked this one because this is one that actually got in. Introducing scope. Then scope predicts how a conversation, semantic space, therefore can be represented a path, and our goal is to search for the... Yeah, it says here, every conversation can be represented as a path in semantic, and our goal is to cumulative reward. Yeah, there's something like about the way that they write this is just like, it's like, here's our original ideas. This is what we're going to do. Whereas this is like training objective. We experiment with different values to assess the impact on compositional generalization. Okay, fair enough. But there's just like nothing more to it. It's like why are you doing that? And like, what do we expect to see and stuff of that nature? It's like here, there's like just so much, there's so much detail. And I'm not saying that all like the length of the paper necessarily dictates its quality. You can have really good, really short papers and really bad, awful long papers. But just the kinds of, just the way that these papers are structured just gives off different vibes altogether. Right? They even predict, like, here's the algorithm, right? Here's like the algorithm. I guess here they just wanted to tune the, I guess they just wanted to change the loss function. So I guess that's not even maybe a fair comparison, but experiments. Okay. Here's the experiments. How do they write the experiment? Okay. Look at the experimental setup here. Yeah. Let's take a look at the experimental. Yeah. So experimental setup is in section 4. Okay, so here's section 4 of the AI scientist's paper, experimental setup. Okay, it's actually pretty, it's one of the longer sections of the paper. No, wait a minute. Oh, so the experiments was here. Oh, they combined the experiments and the results? Okay, is that a common thing? I don't know. Okay, I guess they do that. Okay, fair enough. To project conversations. Main results. Yeah. I think also too, it's just like, and again, I don't want to be to be mean here, right? But it's like, when I look at these two papers, it feels like one group really spent a lot of time on this thing, and this one just kind of feels like they kind of phoned it in. Not to be too harsh, but it feels like there's a clear discrepancy to me, at least, that this one paper, this one has a ton of like probably appendix stuff. Yeah. But yeah, I mean, I think that it's just missing like a lot of the, like, I guess the theoretical mathematical underpinnings the Sakana AI scientist is, I mean. Yeah, like this just feels really, really abbreviated in a way. I think that was the best way to describe it, Lloyd. Thank you. Abbreviated in contrast to human scientists writing. So yeah, I mean, what does this all mean anyway at the end of the day, right? So, like I was talking about earlier, while I think it's impressive that the AI scientist can do what it's doing, we have to give it some credit. It goes end to end, right? Supposedly, it goes end to end in terms of coming up with the experiment and coming up with the code to do it and making the figures and putting the paper all together, right? When you think about all that goes into doing that, and the time it could probably do that in comparison to a human, then I think it's very impressive in the sense that if you asked a human to put in this kind of effort, or to make something that looks like this kind of effort, and generate the kinds of plots you're seeing here and come up with the idea, the AI scientist has the human beat in terms of how fast it can do it, because this could probably do it. They didn't say how long it took them to make this paper, but I would gather it takes them, a human would probably take several days to do this, because just knowing what it takes to like format this stuff, I know the papers, like the figures aren't even that great, but to format it in like the LaTeX document and stuff like that is annoying, just to get it just right and things like that. Is it best practice to be extremely detailed as you explain topics throughout the paper, or is it best to be more brief in the main text and use appendices instead? I think it depends on the topic at hand, I mean, the appendix when I wrote papers was really like if I had like extra tables and things. I usually kept the details in the main body of the paper itself. That's more of like a preference thing. For AI, it does seem for AI papers, a lot of things are often relegated to the appendix when it comes to like additional experiments and what else did I want to say? Additional experiments as well as more of mathematical derivation kind of things. Like I think it's totally fine in that sense. Like if it is very math heavy like this, to maybe show the proofs in the appendices and then just showing the results from your proofs in the main body of the text. I think that's totally reasonable. Wait, it cites Chelsea Finn. I just heard her on the No Priors podcast. Oh, Chelsea Finn. Okay, I don't actually see. Is she there? Where was that? Finn? Oh, there we go. Cool. I didn't know who that. I'm gonna have to look that up. Citation number 1. Okay, cool. Thank you, Lloyd. AI takes minutes to create a research paper. This is true in the sense that the AI scientist probably, did this in, less than an hour, perhaps. I'm not so sure exactly, but wouldn't, or, a couple of hours. I think the best way right now, as it is, this is a great, like, if an AI scientist was just handed this paper, like, if you're like a really competent AI scientist or researcher or grad student, and you were just handed this kind of rough draft of an idea and some basic experiments, I don't think it would be hard to take this and then just add on to it, right? Like a human, like AI scientist paper, like AI scientist work here plus a human would probably produce a pretty good acceptable paper. Probably instead of getting 6.76 scores, you could probably get, probably 7, 8, 9. I don't know how high it goes up to. I'm just guessing 10, but you know what I mean? Like, I think that it right now, if I could use the AI scientist and it could do like a lot of the grunt work for me, then it would be very helpful. But I wouldn't. It's like with anything with these AI models, right? Like, I don't trust it to go end to end completely. It's like I need a human in the loop to like read it and then augment what it's done, right? Because this is not a bad start, okay? But it's not an end product to me. Like, to me, this is like a very, very rough start for, a final published paper. And I know I got through peer review, but again, this is a conference, not versus like a journal. And, we're kind of making a distinction there. Let's see. It would be interesting to paste the AI paper into ChatGPT and see a good. Okay, let's just. Maybe we could just try that. I don't know if people want to see that happen, but we can take a look. Oh shoot, why is my thing loading? Okay, good. Let me see. Give me a sec here. What happened to me going to bed early? We're gonna take a look at one paper, and we're gonna download the raw file. Oh, I already downloaded it. Okay, so let's get ChatGPT in here. Okay. Let's see here. Does ICLR have a rubric itself? Let's see. ICLR workshop paper rubric. Is there like a rubric here? Author guide. I'm trying to see if there's like a reproducible reviewing process. Okay, so maybe I'll ask it to like read this page first. Give me a sec here. Can I get it to look at this page? I'll just say like, okay, read the author's guide on from ICLR 2025. And maybe I should actually set this up to like O3 Mini. Oh, I've also gotten rid of my Pro tier subscription. Apologies, I'm just on Plus now. So the highest model I have at the moment is O3 Mini High. So I think I will use this one to review it and come up with a sensible rubric for assessing a submitted paper. to the workshop. Let's see if it can do this. Okay, can it go here? Searching the web. Uh-oh. What happened here? Okay. Okay. Guideline. La 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 la. Oh, Claude Web Search would be good too. Actually, let me get Claude Web Search here because I actually have not tried it yet. Late night, I got caught with the itch and missed the thing. There's the day, Kyle. Oh, hello. Good to see you. I think I turned it on. Did I turn it on already? Did I turn on? Great. This is confusing. How do I check my web search? Okay, I did turn web search on. Okay, good. Oh, hello. Okay, so let's see if I can give it the same prompt and then let's have it come up with like we'll have two separate AI graders here. If Claude Sonnet 3.7, I'll give it extended because it's also. Oh, can extended kind of access links? Oh, can extended not? Oh, really? Can I just give it this author's guide? Okay, how about this? We'll just give it the author's guide as like a document to look at. Yeah, that might be just better. Okay. Okay, we'll get around it by having Claude just look at the PDF of the author guide. Let's see here. Okay. Can you share the link of that? Share the link of what now? Question mark. Okay, let's see if we can have it read the author's guide. Yeah. Okay, we can give it the same. Okay, so let's do this, and we're going to use extended. All right, so here we go. Okay, so while it does that, I'm going to ask ChatGPT to grade at the following. Oops, let's go to. Let's see. I'm going to give it the paper. Yes, here we go. So this is the actual paper that got accepted. So I'm going to say, what? File upload fail. Oh, dang. Okay, let me try this again. Okay, come on, upload, please. Please. Okay, okay. Read the submitted. Okay. Based on your rubric for the ICLR 25 submission requirements, grade the following paper according to it and assign a final score of from 0 to 10, where 0 is a very bad paper and 10 is a very good paper. Okay, I don't know. That's very generic, but you know what I mean. Hopefully you can understand my request here. It didn't properly cite the guy who apparently everyone never gives credit to. Oh, this is kind of cool. All right. Okay. Oh, there's no explicit. Okay, well, maybe it's but it's not clear. I'll give it for this category. Okay, over here, adherence is solid. I'm kind of curious to know. It's mostly good. Like, so you have a score. Obviously, it's lower. It's extended. In most negative results. Technical quality. Clarity is also a bit underwhelming, so it also earns. See, that's what I meant too. Clarity 5 out of 10. There are no major exits, so I'll leave it at 7 to 10. Okay. A reasonable final score could be 6.5 to 7 out of 10, which is funny because that's actually a final score that it got from the humans, actually. So this did get a 6. That's pretty interesting. Chat GPT did get a 6 here. Give it a 6. Well, that's interesting. Let's just see here. Technical quality and soundness, weaknesses, incremental contribution. Straightforward approach. So you have target, novelty, and originality. Technical quality and soundness. LSTM. Inconsistencies, 6 out of 10. Okay. It says analysis sometimes is not fully reconciled with the experimental figures. Yeah, it's funny. I mean, I said like 5, right? And it gives it 6. And then the human reviewers also gave it 6 and 7 and 6. So this is actually kind of interesting. So Claude also has made its own rubric. So I'm going to have Claude come up with its own assessment really quickly. No ethics statement, overall score, 6 and 10. Perhaps more. Yeah. I mean, that's kind of, I think that's more or less how I felt about it. Okay, so anyways, that was the ChatGPT result. Let's give it to Claude really quick and then let's just see how this goes. Can drop this in here, and then we're just gonna see what it says. Okay, what does Claude say? Maybe the humans used ChatGPT. Okay, I'll share the link while this is going. Here we go. Oh shoot, we got this. How do I share the chat here? All right, peeps. Here's the chat. Here's the ChatGPT conversation I just had. It's gonna be in the chat. Oops, sorry. Let's see what it says here. 5, 6, 5, 6, 8, 5. Weak reject. Ooh, we got a weak reject. Oh, dang. The overall assessment was a 5. Dang. So Claude more agrees with me than it did with ChatGPT, though it's pretty close either way. Hang on, where did I put my YouTube live thing? Here we go. There's my chat here. Yeah, so let's just see what it says here. Submission compliance, it's within the page limit. Scientific contributions of 5. Reasonably straightforward. Theoretical foundation. The related work statement is notably incomplete and too general, and is mentioned in the marginal comments. The citation of Mammal seems inappropriate. Okay. Technical quality, 6 out of 10. Paper presents a series of experiments evaluating the proposed approach and arithmetic powers from the quality. Inconsistencies between hyperparameter values. Oh, they're inconsistent between the hyperparameter values reported in the text versus the actual values used. Definition is imprecise. Is Claude Thinking smart? I think Claude Thinking is really smart. I mean, I think Claude 3.7 Sonnet, to me personally, is the best model for coding. And I use it like, when it comes to anything with a problem with coding, it like one-shots every problem. Or 0 shots. Whatever it means it gets on the first try, it like will get it. Pretty crazy. Like I had this thing the other day where I was like, I really need this not so easy thing to do. And I described in detail to Claude 3.7 Sonnet Thinking, and it got it in one shot. And it was like, wow, that is amazing. So yes, I really think Claude 3.7 Sonnet Extended Thinking is quite incredible. I wish I also knew how many times I can use it, because I don't ever know what my limits are and my rates are. So yeah. No mention of no reproducibility, inconsistencies, exact nature, ethical considerations, confidence 4 to 5. So it says here, publishing is valuable for managing the field, limitations, weaknesses, several inconsistencies, captions undermine credibility, poor theoretical justification. Yeah, this is kind of the thing I was thinking. I couldn't like word it properly, but yeah, poor theoretical justification. Inadequate and figures are sometimes misinterpreted. Yeah, I mean that's basically kind of I felt like. I mean, when it comes to figures are being misinterpreted, that just makes me. It just makes me feel like, does it actually even understand what it's really doing? You know, like it makes me question, like, if it can't understand its own results. And you know, I have to think back. Do humans always understand the results? No. Okay, fair enough. But Yeah, I mean, this is this is why I think this is kind of like a I don't want to say a controversial take, but kind of a non-intuitive take. I actually think that human intelligence in the meantime, in the interim, where the models are not complete, cannot be completely autonomous, but can be, shortcuts or really powerful tools for humans, and not like completely autonomous agents in their own right that can do things end to end flawlessly. I think in that interim, that's where human intelligence is actually going to be really valuable in a way, which is kind of odd because you think, oh, human intelligence is becoming less valuable. But I'm just reading, like, if you go on Reddit, and I know Reddit's like always, Reddit, whatever. But if you go on Reddit and you like read like the CS page or other threads like in tech and stuff, like people in school or like university Reddit or whatever, like, so many people are just using AI to do their work, right? But then it's like they don't actually know what it is they're trying to do, right? It's like they've asked AI to do everything for them, and then when the second they're asked to do something by themselves, it's like they can't actually do it. And so, in a way, it's like when there are real problems that need to be solved and AIs can't solve them, and the humans who have created the mess because they've just been using AI without actually understanding what it is that they're doing, that actually in a way can cause more delay and hold up than before, where you didn't have AIs doing this. So actually, in a way, I do think that this is a good time. People are thinking, oh my gosh, like, oh, we're so screwed. Like, we what's the point of studying hard or going to school anymore? The point is actually, I think people are getting lazier, and because people are getting lazier, there are going to be more inefficiencies in systems, like in people's workplaces, right? Because people, it's just already starting, right? If you like read, who's that guy, vibe coding, right? People have been talking about vibe coding, right? Right, this person even saying how vibe coding can destroy your project. What is vibe coding? Why I hate it. Vibe coding actually sucks. People are already kind of talking about just the downsides of vibe coding. I mean, there's also a lot of like good vibe coding thing too. Vibe coders are struggling. But yeah, the vibe coders, like, here's the thing. I don't actually like to vibe code completely. Sorry, what does Curtis say? We have already had the problem. Us businesses have given the world everything, and now they pay us nothing. We should be the most highly compensated, and we are paid wages like we are monks. Yeah, Curtis, I hear ya. I hear ya. Are all these AIs DeepSeek offshoots? No, I don't think they're DeepSeek offshoots. Let's see. If it's not 100% automated, we are actually going to have a lot more jobs, higher paid, leverage jobs. Google, Gemini, can understand and say YouTube, and expensive. Interesting. What is this? Pay principal AI coding is better than vibe coding. Yeah. Yeah, this is the thing though, guys. Like, I actually think vibe coding could be the not the make or break, but I just think for now, and who knows, if super intelligent AI comes around in the next 2 or 3 years, everything I'm saying here is going to be invalidated. But I do think that human intelligence at the moment actually, like, if you're actually a human who wants to combine your intelligence with AI as opposed to abdicating complete responsibility to an AI and just making an AI, like, for example, like, it's one thing if you can get like Claude, right, to do your physics homework for you or your computer science homework or whatever homework, right? Like for example, let's say you go to, let's say, let me just put a different chat, right? Like, if you're in high school or first year in college, whatever, and you say, oh, draw me the Lewis dot structure for, I don't know, CH4. I don't know what, methane. Okay, it's probably not the heart of a Lewis dot structure to draw. But yeah, okay, so right, and you just do that. And then you don't even like read this stuff underneath here. You just kind of take this drawing, okay? Like, do you really understand why there's a Lewis dot. Like, why do you have these singular lines? Like, why is there, like, these these covalent bonds? Like, will you even understand what a covalent bond is if you just draw this, right? Or if you said, like, draw me the Lewis dot structure for, I don't know, HCO. Okay, I don't even know what HCO is. Is that actually a thing? Okay, yeah. Oh, yeah, it's the formal radical. Okay, yeah. Yeah, so that's what are people saying? I need to relearn it. AI are smarter than me in general, but applying them to code just doesn't feel right. I don't need to retain the information because I can just read up on it again. Yeah, this is true, right? I mean, it's good that you have, but like, I still think you need to know how to ask the right question, right? AIs are really good at getting you the proper answer, but they don't necessarily tell you how to ask the right question. And I think that's the skill that a lot of people who rely on AIs too much are lacking in, is that when they're stuck, they don't even know what the right question to ask is. And I think there's just something about that is still very valuable, because I'm noticing it in the younger students where it's like there are interns at NASA that I see, right? And I'm not going to name names, but I've seen some interns, right, who really relied, past tense, on GPT to do some aspects of their work. And then maybe they can generate the plot they were hoping to make, or they can get the result they were getting to make. But if you ask them how they came up with that, or like how the GPT, figured out what the right method was to, make the random forest, fit to their data and do the regression model properly, they'll have a hard time explaining as to like what actually happened there, right? Because they didn't actually come up with the method themselves. Like, they just asked a model to say, hey, fix this for me. And so I think actually what's the real benefit is to like use a model like this, and then you actually have to try and learn from the stuff that comes underneath of it, right? And understand what's going on over there. Google Gemini models can understand videos, what's happening in videos, and what the person in video will speak is the extra details. Yeah. Hello. Some can deadlift way more than others. Humans have limits, but some of us are talented, and we all have different talents. And just like weightlifting, if you exert your thinking, you can solve harder problems. Good morning from Paris. Ooh. Bonjour, ça va? Bienvenue à moi stream. I don't even know if I said that right. Yes. So for people who joined a bit later, what we did is that we talked a little bit about the AI scientist. A little bit. We talked about a lot about the AI scientist. They came out with 3 papers. The AI scientist did that end-to-end wrote a paper that was accepted to this conference. This is not one of those papers, but the conference was ICLR. This is actually a human-written paper from the conference. And what we were doing is that we were talking a lot about what it all means. Does it feel like this is a breakthrough moment in AI? And I have some, to be honest, what's the right word? I have some skepticism about its abilities at the moment. That could all change in a few months to a year's time. But as of this moment, the papers that it produced, I just felt were missing something. And it felt very subjective, but it seems like it's something that also Claude and GPT had picked up on in terms of just, evaluating it based on the criteria that the conference had organized. So it says, when I was in my physics class, ChatGPT was actually excellent explaining why something was true rather than me just memorizing formulas like I would have done. Well, that's good. I mean, I think that's the thing, though. If you really want to ask it if you know the right questions to ask, and you can have it try and explain to you in a way that it understands, or that you can understand, then I think that's really powerful. Now, sorry, I'm trying to remember how I got to that page because I'm forgetting. Oh, yes, here it is. The GitHub repository with the papers. Oh, yes, here is the paper one. Yeah, so anyways, the papers that it released, I just didn't feel... I wasn't that encouraged. Or maybe blown away. There's a difference between me being impressed and blown away. Like, I am impressed, but I'm not blown away. Impressed is like, yeah, okay. I mean, this was done on a single NVIDIA GPU. Okay, cool. But blown away, again, would probably be me if it was able to do some, like, I don't know. Everything it's doing right now is on the computer, right? Like, everything that it's impressing us with is all based on, like, things you can do on a computer. I'm waiting to see when it moves off the computer and starts doing, like, physical science and observation and measurements and that kind of thing. Then that's when I'm going to be blown away, I think. What blew you away in the past? Yeah, what blew me away in the past? I mean, it's not like I wasn't blown away with OpenAI O1 preview definitely blew me away when it basically came up with the code that I had done for my dissertation work for at least the first year of it. I mean, I think that was just more like a whoa. That was like it was more of a shock that work that I did could have been made a lot more easy. It could have saved me a lot of time. It's interesting. What is that? What is that phenomena where you get like progressively less impressed with AI models? Curtis, I was just curious. Do you own a copy of Gravitation? Yes, I do, Curtis. It's in my office right now. It's not in my home here, but I have that. I have Sean Carroll's General Relativity book too, and then I have one more. I think I've in my apartment. I have 2 like supplementary books. But yeah, I do have Gravitation. It was on sale a few years ago, actually. That's why I got it. It was on sale for like $40, and I was like, oh, okay, I'm going to get it. Being blasé. Yeah, I'm being blasé. Yeah, what's that phenomena? I was reading that phenomena, right? Where you get like progressively less impressed with AI models the more like you've been exposed to them. Because like, for example, the jump from like GPT 3.5 to GPT 4 felt big. Right? Like, I mean, first the 3.5 coming out was like, oh my gosh, what is this? When they first released ChatGPT. And then when they came out with 4, it was like, oh man. Curtis says, I'm going to ask if I can get Roland's copy. Mine is in my garage. Ah, I see. Yeah, rest in peace to Roland. Those of you who don't know, this guy was an amazing scientist who recently passed away last month. Curtis studied under him, but yeah, this thing is called the Winston cone. The Winston cone. I remember when I learned there was this thing named after Winston. I was just like, holy moly, that's crazy. Yes, the father of non-imaging optics. Incredible. So I did not have the pleasure of taking a class from him. I only got to see him a few times give seminars. And to be honest, they were way over my head because I was an undergraduate. Memorial is next month. I see. Yeah. Much thanks to Roland for helping establish UC Merced, where I went to get my college undergraduate degree. So he will be remembered. And crazy that he just came up with this stuff. The Winston cone. It's literally called a Winston cone. My gosh. Okay. Yeah, so anyways, shout out to Roland. Total boss. Honestly, it's also kind of cool because like I feel like UC Merced poached a lot of people from University of Chicago. There was like so many University of Chicago people in our physics department, it felt like. And engineering, I think too. Yeah, I don't know, we just really just poached them. So, hooray. Why did you cancel your pro account? The pro mode wasn't worth it? Yeah, Daniel, it really wasn't. I mean, I just felt like $200 a month is just, how do I justify that? Especially with things like DeepSeek R1 available, you know? You met Sam Altman, didn't you? I did meet Sam Altman in October. So the this is not AI, but no, that was not. What was it? Yeah, there I am. That's him and me. That was not AI. I actually did meet the guy 5 months ago. That was interesting. Kyle, apropos of something else, do you have colleagues who will have time on the Vera Rubin telescope? Oh, most definitely. I need to remember. Which one is this one? Vera Rubin. Sorry, I need to remember which one is this looking for. Yes, in Chile. Yes. Okay. Yes. Definitely. People I know are going to be using this. Definitely. Oh, it's in here. 27.6 feet. Very, very cool. Yeah. Yeah. I don't know. I get these emails still for like funding calls for ALMA. Like, because the telescope I used in grad school was ALMA, right? This one in Chile. And they just released their call. So every year when it's time for astronomers to observe, they will release a call. And since like you can submit a proposal to request time on it. And they just released, I think did they talk about their latest call yet here? News. I always get a little bit like, I get a little bit of FOMO when I see the calls. They're like, oh, I used to look at that telescope. Call for abstracts. Cycle 11 call. Did it not come out this week? Is it cycle 12? Are we already on cycle 12? Wait a minute. Oh, this is cycle 12. Yeah, so it says cycle 12 proposal submission will begin today. Yeah, it began yesterday and it ends on next month. So, could I write a proposal? That would be interesting. Could I get an AI to write a proposal for me that got accepted? That's an idea. Ooh. That's awkward if it got accepted and then I'd be like, oh wait, do I actually have to do the science? I just wanted to see if it got accepted. Yeah, let's see here. What do we have here? 4,300 hours on the 12 meter. So what? Ooh, wait. What bands do we have? We get bands C7, baseline C7, C8. I think it goes up to C10, right? So you look at the handbook here. They always come up with a handbook. Oh, I always love looking at the handbook. The handbook is like a mix between like a telescope manual and also like a radio astronomy textbook, but specifically for ALMA. So wait, what's the configuration here? I'm sorry, guys. I know this is a complete detour here. Did they invite you to that event with Sam because of your video about O1 doing your PhD? I think that's probably the reason why. They didn't say specifically that's why, but I did get reached out to by someone from OpenAI on X to come to the event. Was free for me. The ticket was normally like $400, so that's why when I got invited by this OpenAI employee, I was like, yeah, I'll go. If it's normally like $400 and you're giving me a free ticket, I mean, how can I not? Yeah. What's your conclusion on ChatGPT Deep Research after having used it for a while? ChatGPT Deep Research. Okay, I'm going to be frank with everyone here and very honest. I am feeling very overwhelmed with the number of tools there is, to the point where I feel like I haven't had enough time to thoroughly test all of them because there's always like a new one coming out like every week or so. And so I do think that Deep Research from ChatGPT, when it first came out, I guess I don't know how long ago it was better than the Google Gemini Deep Research. And I think I would even say better than the Perplexity. Yeah, it was definitely better than the Perplexity deep research. But since then, I don't know what strides have been made on either of the other competitive models. Well, actually, no. I did try the Gemini deep research, like version 2 or whatever. And I thought that was much better. Still not as good as the OpenAI one, but much better. Haven't tried Perplexity's new one, if they've come up with a new one. So I think that there's so many tools coming out, and I have yet to like fully think of all the use cases for all of them. And so I feel like it's like my time on using all of them have kind of diminished. Like right now, like most of my AI usage is like using Claude to help me code. Okay, that is like most of my work these days. It's just like using Claude 3.7 Sonnet extended thinking for really hard problems, and then Sonnet regular for much everything else. But I'm not really thinking about using deep research for much of anything at the moment, other than if I have like a curious idea of like, like I'd like a report. I've had deep research like write me reports on like, I'm like, okay, I'm really into like exoplanets right now and like astrobiology and like life outside of Earth. And so I've been like, I asked like deep research, like, oh, find me all the articles that have to deal with like exoplanets and machine learning and stuff like that over the past 5 years. And I'll do that. And I think that's pretty cool. But then I don't really like follow up on it and actually read all the sources it gives me. I mean, I read the thing that it outputs, but I don't read the thing, like all the, 50 resources that it attaches to the thing. So anyways, Kyle, just what you answered with your physics thought experiment. If you have a tunnel through a neutron star and you shine a light from the center of the surface, would you measure a redshift? Also curious what AIs would answer. If you have a tunnel through a neutron star and you shine a light from the center to the surface, would you measure a redshift? Yeah. I would be surprised if you didn't. I mean, based on my understanding, right? I mean, like a neutron star is like one step from a black hole, right? So it doesn't have an event horizon, but the gravitational field internally. Well, okay, let me think. So there's an internal gravitational field, and then there's the field outside of it. If you drilled a hole through it, yeah, I mean, I would suspect you would have a massive redshift, but it's not hollow. This is tough. Hey, Kyle, loving the discussion. Root Cloud is a game changer for automation. I find them way better than Manus. Have you tried integrating with browser automation? No, I have not actually yet. I have tried that with browser automation. I haven't had access to Manus yet. I've only had, so I haven't really had time to take a look at that. How do you use ChatGPT in your work? Like, what exoplanet stuff do you give it? So I don't work on exoplanets. Like, the exoplanet stuff was just basically like things that I've been curious about. I'm actually going to a conference next month that deals with like exoplanets and machine learning, which is why I wanted to get ready for it. But I don't actually work in the field of exoplanets and machine learning. Machine learning, yes, but not exoplanets. But I am going to go to an exoplanet conference next month in New York City, so that's going to be kind of fun. But for most of my work, it's like data processing things. So oftentimes my work is going to be like, okay, I have like a text file, has a bunch of names of other files, and maybe they have like HTTPS for like a link, right? So like maybe the files, like I have like a list of like 8,000 files in a list like this, but I don't want all the HTTPS www dot things. I just want like the file name at the very end. So then I'm going to be like, all right, hey Claude, like write a script that will like, parse the text. So it'll remove everything, HTTPS www dot all the way up until the point where the file name actually is there. So I'll just have like a list of just the file names. And then it's like, okay, so I have a list of all the file names, and then, those are the kinds of things I use AI for, like not so much exoplanet things. Let's see here. If you shine a light from the center of black, could light turn with you, but it has no energy, so you can't try it. Escapes as a ghost of itself. So no, this is actually it's kind of more of a philosophical question. I mean, because it's like, do you say that it's like an infinite redshift, right? Does infinite redshift just mean that there's like the wavelength has just gotten stretched out from like, you know, the light wave has the wavelength has just gotten stretched out so much that it like the wavelength is just pretty much like the size of the universe, so there is no wave at all. You know, is that one way to think about it? Could the light technically escape, but it has no energy, so we can't detect it? I mean, if it has no energy, is there a wave? You know, I mean, what is a wave but a way of transporting some energy, right? So if it's like, if you're saying that the wave is, it's a wave with no energy, just sounds like no wave. The way to figure out that redshift is to use the interior Schwarzschild. Yeah, I mean, because I think the fallacy there, Curtis, right? That's assuming, like you said here, gravitational inside a body is a constant, so there would be no redshift. I mean, that's the standard Newtonian way of thinking, right? I mean, because that's the shell, or is that the spherical shell theorem from Newton that he proved that like, what you call it, the gravitational force, on something. Sorry, it's like 1 a.m. But the Newtonian shell theorem, right? He had shown that, like, if yeah, as of all the math, and so yeah, the spherically symmetric shell exerts no gravitational force on object located inside of it. Right. I think I read somewhere that like Newton figured out one of those things, and like he figured out like one of these things like pretty quick, and then it took him like 10 years to get the second thing. Yes, that's right, Kyle. The question is what I use to figure out if someone actually understands GR. Ooh, dang. Thankfully, I worked with black holes, so I have to sort of understand it a little bit. The interior Schwarzschild. What does the interior Schwarzschild solution look like? I don't actually remember what it looks like here. Compressible fluid. Oh yeah, look at that. Actually, wait. Can Claude get that? I just want to see that. I'm gonna ask your question, Curtis, to Claude really quick. I'm curious now. I'll give it to extended Claude. Hooray! I passed. Yay! Didn't have to revoke my physics degrees. Okay, there are 3 main types: cosmological, gravitational. Yes, we're dealing with gravitational redshift. When light moves over a massive object, gravitational redshift formula is this. Yes. I think what helps me remember this is just the fact that I've seen a lot of those like diagrams of like black holes and like light cones, right? Of how when you like shoot like light radially from like a black hole, the depending like if you're inside of the event horizon, right, all of the light cones become pretty much what do you say? Like there's just no way to get out of the black hole, right? Like everything just gets down to the singularity. Now it was a neutron star you're asking, but I'm like, well, you're basically one stage away from a black hole, so you still have to deal with relativity. And so and there are those problems, right, of like what's like the closest you can get to a black hole and still get the photon out of like your flashlight, and then how much of a redshift. So it made sense in the sense that it would be redshifted. But I guess I'm curious, like if you drilled a hole through that, something's making me think about if you drilled a hole through a neutron star. Sounds like a really unstable mess. Yes, the null geodesics are closed. There we go. That was the proper term. The null geodesics are closed. Thank you. I don't study the GR as much as that, but yes, that's like the proper term. The killing vectors. I always found those names to be so funny. The killing vectors. And the leader of yes. Okay, yes, there's this formula. Now I want to study GR again. I actually just got this new book. Hold on, let me show you. Okay, I'm back. Sorry. Okay. So as I was saying, there are these like two new books, not two, actually only one new book. I've had this one for a while, but there is this book that I have in my hand. I'm trying to get my screen to like go a bit bigger. Come on. Oh, dang. Why is it so hard to make myself bigger here? I'm in the center of the screen, but I can't seem to make. Oh, there I am. So there's this one, which is like a most incomprehensible thing, which is like one of the first books. Very gentle introduction to the math of relativity. Only goes as much as the Schwarzschild metric. Not so much. Doesn't really discuss the Kerr metric, and doesn't really talk too much about like the differential geometry in great detail. Like you don't learn about Killing vectors there. And then there's this one that I also just got. It's called General Relativity Step by Step, a first course in GR. It's really nice because like I don't know. This person has like annotated like all of the equations by color, which I find to be really helpful. So I'm just going to find a good example of this where they've done that. Yeah, like they've done this sort of color coding here. I don't know if you can see this, but it's like, oh yeah, the green screen is messing it up, but they've like color coded certain equations just so you can be more clear as to like what terms are being canceled and stuff like that. But there was other terms too, torsion, topology, blah, 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 blah. Where is it? All the diagrams are also hand drawn too, which are kind of neat. But where is the ones where they use like different color text for all the different like Christoffel symbol thingies? Dang, if I had time, I'd definitely. Oh yeah, here we go. Like this is a good example. Where'd it go? Like, I don't know if you see all those terms there, but like they really go through like which terms are which in the lines that are coming. So anyways, thought I'd share that. All right. Oh my god, it's almost 1 o'clock. I started this stream saying, "Oh, I'm gonna go to bed soon, guys," and then what happens is that we end up talking for hours. Hilarious. Okay, have you read Einstein's original work? I've read the Ines Morabilis papers a long time ago, like, but the English translation, of course, because I don't read German. But yeah, I read like the 4 papers that was it 4? I feel like it was 4 papers that came out that year. Um, oh yes, I have the Meaning of Relativity on my shelf somewhere over there. I've tried going through it. I don't know why I stopped because I really wanted to go into it. I think is he using the ICT convention back then? Like is he still using like the like ICT special relativity? I think that's kind of why I stopped. And I think I was reading something was I reading something in Misner and Thorne and Wheeler? Um Yeah, the imaginary time coordinate. Because I remember there's a section in Misner, Thorne, and Wheeler that says like goodbye, like farewell to ICT, where they're like, all right, let's forget about like let's not try and pretend that let's not try and put space and time on the same footing and make it all like make the math nicer. Like, let's just accept that our metric must have a different sign for time and space. So, yeah. That is a section, right? Farewell to ICT. I'm pretty sure I saw that somewhere. Farewell to ICT. What is this? Oh. Wrote a section. Farewell to ICT on gravitation, page 51. Aha. Yeah, see? So why is it problematic to regard the Lorentz group as SO4? All right, here we go. Actually, better yet, why not let ChatGPT answer this? Or Claude. Maybe it'll tell me. Okay. Can this work? Oh, come on. I just want to put it in there. People who don't study physics are just like, what the heck is going on? It's 1 in the morning, guys. Let us just chill for a sec. Answer the following. Okay, here we go. Let's see what it says. Unspecified physics question. Oh, here we go. Let me explain. Okay, Lorentz group. The Lorentz group is this. These are special orthogonal group in 4D over the complex numbers because it's a 4x4 complex major complex product. Question is there something upon it? Let me ask you why different structures. So the Lorentz group SO13 is a real Lie group with 6 dimensions, 3 boosts, 3 rotations. SO4C is complex Lie group with 6 complex dimensions. So it's 12-dimensional when viewed as a real manifold. Okay, different signatures preserves the metric signature. 1-3, which means it preserves a quadratic form, would preserve complex quadratics and have the same physical interpretation. Complex versus real, hyperbolic geometry. This is interesting. Do you recommend reading a book, making highlights, and then showing them into AI to make it, or just straight up taking its own summary? I've never tried that, Cat. I've never tried that. Cats. I'll just call you Cats because your name is long, but might be worth trying. Putting your own notes if you're willing to have it incorporate your annotations. I've never tried that, but it's something I think would be worth looking at for sure. I saw a podcast where they were saying people could have discovered special relativity without Einstein, but general relativity may have taken much longer without him. I definitely think that GR would have been nearly, I dare say almost nearly impossible without just his insight. Because the issue with special relativity, right, was evident since electrodynamics because the equations were not Galilean invariant, and so depending on the reference frame that you were viewing, like a moving wire, right, seemed to imply there was some preferred frame of reference. Yeah, I mean, I would go as far as saying like there's just like very little hope because it's like he really just took his, like, the math for GR had been around, right? Because you had Riemann and you had Minkowski and you had Hilbert and all these people, Levi-Civita doing the math, but none of them had Einstein's physical insight. Like, I don't think any of them would have been able to predict like a perihelion. Yeah. Oh, here's an interesting question. Here's a really interesting question, actually. I had this thought because I was thinking about Mercury. For some reason, this past couple of weeks, months, I've been thinking about exoplanets, and so I've been reading a lot about Mercury, right? And Mercury is like the example it's always you like the 43 arc second per century perihelion shift of the perihelion of Mercury, right? That was like the major confirmation of Einstein's theory, or like the thing that convinced him that he had done things right because of Mercury's close orbit to the sun and it not being a completely classical Newtonian orbit. And I had this random thought, and I was like, if we didn't have Mercury, because there's no guarantee we didn't need Mercury per se. Mercury is the closest planet to the sun, but I'm not saying we didn't. Like, Mercury's a very small planet, and like in principle, we didn't need Mercury, right? And so without Mercury, would we have ever discovered general relativity? This was the thought I had the other day. And I actually don't know. Like, could Einstein, I guess he could have detected the deflection of light. Like, you could still use the eclipses, which is what Eddington did in 1919. But yeah, like without Mercury, if there was no like deviation from Newtonian mechanics in this kind of widely known example, could we have still come up with general relativity? Could Einstein still have come up with general relativity? My answer, I think, would probably be yes, but like, because I think he would have probably he probably would have had the insight to figure out the whole like bending of light thing and have a test with the eclipses, but let me just I have a question here. I mean, curious to know what AI thinks. Let's see. Hypothetically, if Mercury was not present in our solar system, um, I don't even know how to ask this because I feel like I'm asking a person. Kyle, we need to talk. I like the way you're thinking. Oh, thank you. I like the way I think too sometimes. Was not present in our solar system. Could Einstein still have developed general relativity? Yeah. I'm trying to think. Okay. Like these are counterfactuals, right? That is a thought-provoking hypothesis about scientific discovery. While Mercury's orbit was important for coming, Einstein likely would have still developed without Mercury in our solar system. His primary motivation came from theoretical considerations rather than Mercury's orbits. Anomaly. Einstein was driven by this. Other. Yeah. Yeah. Like I was thinking this too. I was like, he probably would have figured. I mean, if it wasn't Mercury, he probably would have just realized that gravitational redshift could, and like lensing could be used to test this idea. But sometimes I wonder if like how much of a driving force was that sort of discrepancy with Newtonian gravity. Because did we really have that? You know what I mean? Like, was there any other really known example of a really discrepant Newtonian versus Einsteinian description of gravity besides the precession of Mercury's perihelion? Anyways, so ask yourself this: did you know that parity symmetry violation was discovered 1 year after Einstein died? He didn't know the real symmetries of nature when he developed GR. That is pretty insane that he did not know that. I did not know that parity, because I know he didn't really work on those kind of particle like CPT stuff that ended up becoming important for particle physics in the 60s and 70s. But yeah, didn't know the real symmetries of nature. Pretty insane. I honestly would love to bring Einstein today. Like I've been asked that question of like, oh, if you could have like dinner or coffee with like one person from history, alive or dead, who would you bring? It's always Einstein. Oh, good night, Daniel. Hope you have a great night. Thanks for stopping by. But yeah, if I could have a dinner with anyone, dead or alive, it'd definitely be Einstein. Because I would just love to be able to like talk to him about, like, if we could bring him to the modern day and have him think about what's going on now, gosh, it'd be so cool. I wonder if he'd be kind of sad though, in the sense of like we hadn't solved, like we still really haven't figured out like what quantum mechanics kind of really means, and the fact that we've been kind of stuck on finding a grand unified theory, which is what he was going for. But I wonder if he'd be impressed with like the standard model and like, the black hole pictures and gravitational waves. I feel like it would just be like, well, I told you so. But actually, no, the black holes, he wouldn't have said I told you so, because, he didn't actually think black holes were real. That's the thing. He actually said this quote about the whole Schwarzschild singularities, like Einstein, Schwarzschild don't exist. Yeah, where did he say that? He had written this paper. Let's see, 1939. I believe it was 1939. He wrote this paper. No, yeah, he says on a stationary system, spherical symmetry consisting of many gravitating masses. Yeah, so he pretty much said that Schwarzschild singularities could not have a physical analog in the real world, which is kind of funny and ironic. Oh, okay. He would have liked Kerr's paper. No, I bet. That would have been so cool. Yeah, because he died in 1963. He's never been wrong. The one time he thought he was wrong, he was mistaken. Are you talking about the cosmological constant? It's funny though, actually, if you watch what's his name? So if you go to the MIT General Relativity open courseware, I actually watched this video. Oh, it's me. What do you know? My video comes up here. So yeah, I watched this whole course on MIT 8.962 on general relativity during spring 2020. Kind of amazing because that was actually, this is in the middle of the pandemic and stuff. So yeah, I took, well, I took cosmology and I learned GR in pieces from my cosmology class, and then this, and then some self-study. I've never taken like a proper formal GR course, which I know is kind of like amazing, but the one time they offered it in my don't ask, my grad department was like, I don't know, crazy. But anyways, so when I was studying, what was I even trying to say? I was just trying to say something about GR. So probably something about Einstein. Oh yeah. So as I was saying, this professor, Scott Hughes, I believe is his name. Yes, Scott Hughes. He was talking about in this course how I think he was like in Germany, and he was like at the, he was at like this museum or whatever that has like Einstein's old notebooks, and he was saying that you can see in Einstein's old notebooks where he made mistakes and he crossed things out and was like, oh no, this is wrong. And it's just kind of cool to imagine how Einstein was really struggling. I mean, people forget it took him 10 years to go from special to general relativity. Like 10 years. Like I can't imagine just the amount of concentration and determination to keep working at a problem like that for 10 years, I mean, there's people like Andrew Wiles, right, who like spent like 7 years in Solidarity to solve Fermat's last theorem. But it's just crazy. Dude, it's 1 a.m. in the morning. Thank you very much. Current paper things and noticed this last year. Yeah. Yeah, I do remember that, Curtis. I do remember that. Roy Kerr calling out Penrose and Hawking, I suppose. I've been working on it for 20 years. 20 years. Oh my. It's a long time. Yeah, I mean, I'd like to get back to this if I had more time to do more GR things, but my job doesn't really require that at the moment. It's 4 a.m. and I get to sleep to this. All right, I think it's about time I get to sleep because I have a thing at 9 in the morning tomorrow. Oh shoot, I gotta get up for that. Oh gosh, I have a thing tomorrow. All right, I'm gonna set my timer for 8:30. Thankfully, I'm gonna just work from home tomorrow, so that will be my thing. Okay, so I'm gonna go to bed because I have a event at 9 in the morning tomorrow. Yeah, work tomorrow too. Okay, good luck at work tomorrow, Curtis. And thanks for everyone for stopping by. I know we were talking about the AI scientists at the start, and then we kind of devolved into some non sequitur and tangents, but hope you found it interesting nonetheless. And final thoughts, AI scientist, 5 out of 10, in my opinion. And that's kind of was not verified, but corroborated by the both the human reviewers and the AI reviewers that I made in this channel. Just feels like it's not quite there in terms of the rigor and the depth of its reasoning. But nevertheless, really cool that I was able to go from start to finish, making the paper, doing the test, making the plots, all that stuff. With more test time compute, can it get there? I don't know. Maybe. But remains to be seen. All right. Good night, everyone. And